All right, we are moving on from multiplying and dividing exponents to looking at products of powers. And what that means is we are going to start to see problems that look like this with two exponents. So simplify 3 squared to the 4th power. So if I think about 3 squared to the 4th power, that just means that I have 3 squared 4 times. And thinking back to yesterday, the multiplication rule says that if all of the bases are the same, which they are, they're 3's, that I can just add our exponents. So 2 plus 2 plus 2. If I add all those 2's up, I get 8. Now, let's look at to see if there's a quicker way than writing all of that out. Look at this and look at that. How did we go? We kept the 3, but how did we go use that 2 and the 4 to come up with 8? Yep, we multiplied it. So 2 times 4 gives us 3 to the 8th. So whenever we have two exponents, we multiply them to get our new exponent, our simplified version. Okay, so simplify 3 to the 3rd to the 2nd power. So we keep our base of 3 and then multiply our two exponents and we get 3 to the 6th. Describe the relationship between the exponents of 3 to the 3rd raised to the 2nd power and the exponent of 3 to the 6th. Well, this was our starting problem from up here above, and this was our answer from up above. So I could probably say that these are equal. That's how they're related. At the bottom here, we have to simplify 5 to the 8th to the 6th power. So keep the 5 and multiply your two exponents. 8 times 6 would be 48. So 5 to the 48th power. 953 to the 7th raised to the 3rd power. So keep that 953 and multiply your exponents. So 953 to the 21st power. This is just your generic rule of anytime you have the base raised to an exponent and then raised to a second exponent, you keep that base and you multiply the two exponents. The only time this does not work is when n would equal 0. So for this to be okay, n cannot be 0. Our base cannot be 0. Okay. Now look at how to simplify a product of powers when the bases are different and the exponents are the same. So simplify 2 to the 3rd times 4 to the 3rd. Write an expression without exponents that is equivalent to this. Well, 2 to the 3rd power means 2 times 2 times 2. And we're multiplying that by 4 to the 3rd power, which would mean 4 times 4 times 4. Now apply the associative and commutative properties of multiplication to write your expression as the product of groups of 2 times 4. So if I paired up a 2 and the 4, how many pairs would I have? I would have 3 of those pairs. And then I could simplify 2 times 4 in the parentheses to be 8, and we have an exponent of 3. So let's take a look. How did I get from here all the way over to here? Well, I kept the exponent of 3, but I multiplied that 2 and the 4. So you don't have to write it all out like I did here. You can just look at those two bases, multiply them together, and keep the exponent. And that's what this says right here. This is our generic form. When A and B are different numbers, you multiply them together and the exponents are the same. This only works when those are the same as well. Then you keep that exponent. And A and B cannot be 0. So they have to be regular numbers. All right, We have two problems to try here to show what we learned. 2 to the 18th raised to the 8th power. So we would keep the 2. And because we have an exponent raised to an exponent, we're going to multiply those. And 18 times 8 is 144. And then our last problem here shows different bases. So we have 4 and 25. So we're going to multiply those. And both of them have the exponent of 9. So we're going to get to keep that 9. 4 times 25 is 100, and to the 9th power.